Hi everyone, we're here at the Joyceville Side Road outcrop at the south end of the outcrop. My hand is on the syenite Precambrian rock. We have an unconformity and then we have the Ordovician limestones on top. One very cool feature about this unconformity, if we look down the outcrop just a bit, we have these boulders of syenite that are encased within the younger limestone. So you can actually trace with your finger the outline of this boulder. And there's another one here that was plucked up from the existing syenite rock at the base of the limestone as it's forming and sediments are depositing in the Ordovician seas. Hi, so we're still at the Joyceville outcrop, a little bit toward the north end of the outcrop. Here we're looking at another age relationship feature. We have the syenite basement rock that we just looked at in the last video clip. And here we have a diabase dike that's cutting through the syenite. So you can see the boundary or the contact between the syenite and the dike on this side, and the boundary over here on the other side. Hi, so we're still at the Joyceville Rd outcrop looking at the syenite, and you'll notice that there are quite a few fractures cutting through this igneous rock. And the type of fractures that are really common, like the ones we're seeing here, are joints. My hand is resting on the surface of one joint, and I'll walk along this outcrop now and point out how this set repeats and the orientations of other sets and how they repeat. So there's our first set. We have a horizontal set cutting into the rock outcrop. We have a third set dipping the other way. Again, we have this horizontal set and this vertical set facing the road. We can see that the vertical sets repeat at certain intervals, and this is a very important measurement for engineering geology purposes. And we also have a minor or less persistent joint set in this orientation. So if we keep going on this outcrop, you can start to pick out how these joints repeat themselves. And in this section, you'll notice there are fewer horizontal sets. There's one a bit further up, which continues persistently through the entire outcrop. And if we keep going over here, there's a very interesting feature we can look at. We've talked about faults and slickenlines and slickensides. Well, here's a perfect example of slickenlines on a slickenside surface on a fault in the Kingston area. So we can see, if we take our pencil, this is our fault surface, and you can see the dominant linear features that are parallel to my pencil. That would be the slicken lines showing the direction of slip or net slip on this fault surface. Okay, so we've returned to the first joint I had my hand on in this outcrop at Joyceville Side Road, and we now want to measure the orientation of this joint surface. And remember that to measure this, we use strike and dip. So if we have our Brunton transit compass, and following the right-hand rule, we take our right hand, put it on the outcrop, so our thumb is pointing in the direction of strike, and the rest of our hands are pointing downslope in the direction of dip. So we take our compass now, we put the entire edge, lower edge of the compass, on the rock surface. We are leveling the level bubble, and once that is level, we look at the north arrow, and in this case, the strike following the orientation of the plastic pointer is oriented at about 139 degrees. And then when we go to measure strike, remember we turn the compass 90 degrees. We'll use this dial on the back to adjust the clinometer. I'll flip it around so you can see the numbers. And so as we are adjusting the clinometer, we're watching the long level, and we're watching for the bubble to cross. Now, I've reached the end of the 90 degrees on that side, so we'll flip the bubble the other way. And now you can see the bubble very slowly getting toward the center of that clinometer, and that's our dip measurement. So we take our hand off the dial, the measurement is preserved, and we can read it off at a more convenient angle. So in this joint, we have a dip of about 80 degrees. So we would write in our notebooks, the strike, 139 is 139 degrees, and the dip, after a forward slash, 80 degrees. And that's strike and dip for this joint on the syenite outcrop at Joyceville Side Road. Hi, so if we're looking at the syenite outcrop in a bit more detail, trying to look at the minerals to determine the mineralogy and therefore a specific rock name, we generally want to draw our eyes to the fresh surface where the minerals and the mineral grains in terms of their color, texture, shape, and cleavage planes and whatnot are most visible. The outcrop, you'll have noticed, also has weathered surfaces that, in this case, obscure many of the minerals, and it's very difficult to see any mineral grains, and there are differences in colors. Some of this color difference on the weathered surfaces is because of lichen, water running over the surfaces and things like that over time. And so it's really important when you're looking at an outcrop to make sure you look at both the fresh surface and the weathered surface and characterize or make notes of what they look like in your notebook. Although in this case, many of the minerals in the syenite we identify with the fresh surface, there are other cases of weathering, such as I've talked about in class, where potassium feldspar and other minerals can actually stand out quite nicely in a weathered surface.